Hello friends, welcome to our channel STLT Electrical and Electronics Engineering. Today here I am going to discuss about busbar system part 2. Indoor busbar system inside metal panel. The cross section of busbar should be such that the current density for aluminum conductor is 1.2 ampere per square mm. Here is the ampere. Here is the aluminum busbar size in square mm, and here is the weight per kg meter. Weight kg per meter. Here is the weight kg per meter. Here is the difference ampere 100, 200, 300, 400, 500, 600, 800, 1000, 1200, 1600, 2000 and 2500. And here is the size of the aluminum busbar in square mm. For 100 ampere 20 into 5 square mm, 200 ampere 40 into 5 square mm, 300 ampere 50 into 5 square mm, 400 ampere 60 into 5 square mm, 500 ampere 75 into 6 square mm, 600 ampere 50 into 10 square mm, 800 ampere 60 into 10 square mm, 1000 ampere 100 into 10 square mm, 1200 ampere 120 into 10 square mm. And here is 1600 ampere. Here two numbers of strips of aluminum bars, two numbers of strip into 80 into 10 square mm. Again for 2000 ampere, two numbers of aluminum busbar strip into 100 into 10 square mm. Again for 2500 ampere, two numbers of aluminum busbar strip into 100 into 15 square mm. And here is the weight kg per meter 0.268, 0.538, 0.673, 0.808, 1.215, 1.35, 1.62, 2.7, 3.24, 2 into 2.16. Here two numbers of aluminum strips, so here 2 into 2.16, again 2 into 2.70, again 2 into 4.04. Okay, next. Here in our busbar system inside metal panel, the cross section of busbar should be such that the current density for copper conductor is 1.6 ampere per square mm. Previously it was aluminum busbar and here it is copper busbar. Ampere is same 100, 200 ampere, 300 ampere, 400 ampere, 500, 600, 800, 1000 ampere, 1200 ampere, 1600 ampere, 2000 ampere, 2500 ampere. The corresponding copper busbar size 20 into 3 square mm, next 25 into 5 square mm, next 40 into 5 square mm, next 50 into 5 square mm, 60 into 5 square mm, 40 into 10 square mm, 50 into 10 square mm, 60 into 10 square mm, 80 into 10 square mm, 100 into 10 square mm, 120 into 10 square mm, 160 into 10 square mm. The weight of the copper busbar is 0.53 kg per meter, 1.11, 1.77, 2.22, 2.66, 3.55, 4.44, 5.33, 7.11, 8.89, 10.7, 14.2. Okay, next. Here it is minimum electrical clearances of indoor busbar system according to voltages. Voltage in kV 0.415, 0.600, 3.3 kV, 6.6, 11 kV, 15 kV, 22 kV, 33 kV. And phase to earth in millimeter, 15.8 millimeter, next 19.05 millimeter, next 50.8 millimeter, next 63.5 millimeter, next 76.2 millimeter, next 101.6 millimeter, next 139.7 millimeter, next 222.25 millimeter. And here is face to face in millimeter, 19.05 millimeter, 19.05 millimeter, 50.8 millimeter, and 88.9 millimeter, 127.0 millimeter, 165.1 millimeter, 241.3 millimeter, 355.6 millimeter. Okay, next. Here it is, Busbar clearances of HT outdoor substation. Here is A, face to earth clearance, B, face to face clearance, C, ground clearance, H, busbar height. Here is A, face to earth clearance. Here is A again, and B, face to face clearance. This is B, this is B, B, B. C, ground clearance. This is ground clearance C. And next, H is equal to busbar height. H, busbar height. Here is the H. This is the tubular busbar. This is the busbar height H. One tubular rigid busbar. This is one. Two ACSR flexible bus. Two. Three column for tower. This is three. Four beam or gantry. This is four. Five support structure. Here it is five. And six post insulator. Here it is six post insulator. And seven suspension string insulator. And this is the suspension string insulator 7. Okay, next. Here it is, minimum electrical clearances of open outdoor busbar system. First 6.6 kV face to earth in mm, face to face in mm. 6.6 kV 140 and 178 mm. And for 11 kV 178 mm and 229 mm. 15 kV 216 mm, 267 mm. For 22 kV 279 mm and 330 mm. For 33 kV 381 mm and 431 mm. 66 kV 685 mm and 786 mm. 110 kV 1068 mm and 1219 mm. And 132 kV 1270 mm and 1473 mm. 220 kV 2082 mm, 2368 mm. And this is 400 kV 3500 mm. And this is face to face 4000 mm. Okay, next. Here it is, selection of busbar height of outdoor substation. How the busbar height is calculated. First, I tell about creepage distance. What is creepage distance? Creepage distance means the shortest distance along the surface of a solid insulating material between two conductive parts. Here is the creepage distance shown is in the dotted line. Here is the busbar and here is the earthing portion, the two conducting part. The marked distance is creepage distance 16 mm per kV for moderately polluted atmosphere, 20 mm per kV for more polluted atmosphere, and 31 mm per kV for heavily polluted atmosphere. In the insulation, on the insulation surface, dust deposit, moisture deposit is occurs. So this is in this path, the conducting of electricity is made. This path is called the distance of the path is called creepage distance. Next, dry arcing distance means the shortest path which the voltage can puncture the air outside the insulator. Height of this insulator should be as per arcing distance and should be verified from power frequency flashover voltage test. The marked dotted portion, the marked distance is dry arcing distance. This is the insulator height. This is a picture of post insulator. The portion is earth portion. Okay, next. Here selection of busbar height of outdoor substation. Ground clearance is the distance from uppermost earth level to plinth level, that is 2500 mm. The ground clearance is practically the distance for for a human person standing on the ground cannot touch the insulator portion of the busbar system. This is taken as 2500 mm. Here is the voltage level in kV, ground clearance in mm, approximate arcing distance of insulator in mm, creepage distance 31 mm per kV is taken, and bus height in millimeter is equal to ground clearance plus dry arcing distance of equipment insulator, height of tank terminal connector, all is in millimeter. Here voltage level 400 kV, ground clearance 2500. Post insulator height is 3650 mm, CT insulator with end casting 3350 mm, circuit breaker support insulator CV support insulator 3850 mm, tension and suspension insulator string is 3625 mm. Now it is added 2500 plus 3650 mm plus height of the tank terminal connector 1000 mm, and then it is 7150 mm, which can be rounded up to 8000 mm. In order to make 8000 mm, structure height is adjusted to make ground clearance more than 2500 mm. Okay, next. Here is again selection of busbar height of outdoor substation. Here is 220 kV, voltage level in kV, ground clearance in mm 2500 mm, and post insulator is 2300 mm, CT insulator with end casting 2000 mm. Here circuit breaker support insulator 2100 mm, tension and suspension string insulators string, tension and suspension insulator string 2175 mm. Now added the 2500, 2300 and 700, that is height of tank terminal connector. The total distance is 500 5500 mm. For equipment with lower arcing distance 2001 mm, 5500 mm is made by adjusting structure height, which makes ground clearance more than 2500 mm. And here it is for 132 kV, again 2500 mm, post insulator 1500, CT insulator with end casting 1190, CB support insulator 1770, tension and suspension insulator string 1450, adding the 4600 for equipment height for equipment with lowest arcing distance 1190 mm. 4600 mm is made by adjusting structure height, which makes ground clearance more than 2500 mm. This is the total procedure. Okay, next. Here is selection of Busbar height of outdoor system again for 66 kV. Ground clearance 2500 mm. Approximate arcing distance of insulator mm is 630 mm. And here is the bus height 4000 mm. And here for 33 kV 2500 mm again. Approximate arcing distance of insulator in mm 320 mm, and the bus height is 3700 mm. Okay, next. The current density of outdoor bus bar are generally taken approximately 2 ampere per square mm. Calculation of size of bus bar from calculation of short circuit current. The minimum busbar size in square mm can be calculated from fault current. A is equal to IF square into TS root over divided by K. A is equal to size of earthing conductor in square mm, IF fault current in ampere, TS time taken by the protective gear to isolate the faulty section. K is equal to factor taking account of heat capacity of the conductor material initial and final temperature rise. Material for copper K is equal to 205 and for aluminium 126. The value of K. Okay, next. Calculation of temperature rise under short circuit condition. The melting point of copper is 1085 degrees centigrade and the melting point of aluminium is 660 degrees centigrade. Copper starts becoming soft at 200 degrees centigrade, so the permissible maximum temperature rise in short circuit condition is 200 degrees centigrade. Copper oxidizes quickly at the temperature above 85 degrees centigrade. Hence, for normal currents, the maximum temperature rise is permissible to 85 degrees centigrade. At about 160 degrees centigrade, aluminium becomes soft and loses its mechanical strength. This sets a limit on allowable temperature rise during short circuit condition. Where space requirement is minimum, there copper busbar are chosen. Otherwise, the use of aluminium busbar is economical comparing the cost. For the purpose of calculation of temperature rise preliminary, the following formula can be used. Here T is equal to K by 100 into IF divided by A whole square into 1 plus alpha theta into alpha theta within bracket into T. Capital T is equal to temperature rise in degree centigrade during short circuit condition. IF, symmetrical fault current in RMS in amperes. A cross-sectional area of the conductor in millimeter square. Alpha, temperature coefficient of resistance at 20 degrees centigrade. 0.00403 for pure aluminum, 0.00363 for aluminum alloy, 0.00393 for pure copper. Theta is equal to operating temperature of the conductor at which the fault occurs in degree centigrade. K is equal to 0.52 for copper and 1.166 for aluminum. Small t is equal to duration of fault in seconds. Okay, next. General formula for calculating the force between conductors in the event of a short circuit. The calculation of the forces in the event of short circuits force max can be defined as follows. L is equal to span length between insulators. This is the L. Here is one insulator and here is one insulator. D is equal to spacing between neighboring conductors in three-phase bus. This is the distance D. L and D in centimeter. ISC means peak momentary short circuit current, asymmetrical in kiloamperes. IF RMS into root 2 into 1.8 kiloampere, where 1.8 is a factor for asymmetry. F is equal to force between conductors in kgf. F is equal to 2.04 into ISC square into L by D into 1 by 100 kgf. However, this formula is only applicable to very long distance L greater than 20 D round conductor. When L is shorter, a correction factor called the end factor is applied. For L by D greater than 4 and less than 20, use formula F is equal to 2.04 into ISC square L by D minus 1 within bracket into 1 by 100 kgf. For L by D less than 4, use F is equal to 2.04 into ISC square into root over L by D whole square plus 1 minus 1 within minus 1 into 1 by 100. This is the general formula for calculating the force between the conductors in the event of a short circuit. Okay, next. As the conductors are supported on insulator, they experience bending forces due to the forces on conductors during short circuit condition. The force is given by the equation 1 previous I am stated. The cantilever strength of insulator should be more than bending force. The cantilever strength of insulator, first noted from catalog of insulators on the basis of which the span length L is calculated. Determination of span length of insulator. Cantilever load on insulator is given by F into H kg meter, where F is equal to force in kgf per span length, H is height of insulator in meter. You get the value of cantilever strength of insulator from insulator manufacturer catalog. Suppose it is say S. Say S. F into H is equal to cantilever load per meter length. F into H into L cantilever load of span length of L meter. So F into H into L is equal to S divided by factor of safety. Factor of safety assumed 4. Then L is equal to S by factor of safety into 1 by FH. Thus the length between the insulator span is calculated. The length of insulator span L is calculated. Okay, next. Selection of busbar system. How to select select busbar system? First one, select the busbar cross section on the basis of normal current rating and current density. Then check the cross section for short time short circuit withstand capacity and permissible temperature rise under short circuit condition. Second, select the face to face clearance, face to ground clearance and busbar height from specification. Third, determination of force on support insulators and select the suitable support insulators. Determine the span length of support insulators. Okay, next. Here is some example or sample of tubular busbar used for outdoor substation. Here is the voltage rating in kV, diameter of tubular busbar in inches. For 11 kV, 1.5 inch copper or aluminum tube. For 22 kV, 1.5 inch copper or aluminum tube. For 33 kV, 1.5 inch or 2 inch copper or aluminum tube. 66 kV, 2.5 inch copper or aluminum tube. 132 kV, 2.5 inch copper or aluminum tube. 220 kV, 3 inch IPS aluminum tube. And for 400 kV, 4 inch. For 220 kV, 3 inch IPS aluminum tube. And for 400 kV, 4 inch IPS aluminum tube. Okay, next. Here is technical specification of aluminum tubular bus. The pipe normal sizes 1.5 inch, 2.5 inch, 3 inch, 4 inch, 1.5 inch, 2.5 inch, 3 inch, 4 inch. Again, this is repeated. This is repeated 1.5 inch, 2.5 inch, 3 inch, 4 inch, and again 1.5 inch, 2.5 inch, 3 inch, 4 inch. It is inch. Diameter in millimeter outside 48.26 and inside 40.9, again 73.03 and inside 62.72 and again 88.90 and inside 77.93 for 4 inch 114.30 mm 30 mm and 102.3 mm 1.5 inch again 48.26 mm and 38.10 mm 2.5 inch 73.03 mm and 59 mm and for 3 inch 88.90 and 73.7 mm 4 inch 114.30 mm and 97.2 mm. The wall thickness of this 4 and this 4 is difference. Wall thickness is 3.7, 5.2, 5.5 and 6.02 mm. And again wall thickness 5.08, 7.02, 7.62 and 8.6 mm. Area also difference of these four and of these four. The first is 516 square 16.13 square mm. Next 1099.35 square mm. Again 1437.42 square mm. Again 2048 square mm. Again this is 699.03 square mm. Again 1454.19 square mm. And again 1945.80 square mm. Again 2844 square mm. The weight kg per meter also difference. The first one 1.396 kg per meter, second 2.980, third 3.890, fourth 5.529, again 1.87, 3.94, 5.27, 7.678. And here is the DC resistance at 20 degrees centigrade: 60.73, 28.44, 21.75, 15.30, 45.44, 21.52, 16.11, 11.00. Current rating in amps: 1160, 1950, 2350, 3050, 1335, 2230, 2700, 3590. Okay, thank you for watching the video. If you think the video is useful to you, then please subscribe our channel and share it to your friends. Okay, bye. See you in the next video. Okay, bye.